Welcome back to NQuest Edu Physics students. Here in this class we are going to learn about coefficient of restitution. Actually, it is the Newton's experimental law. In that we have a relation. Earlier we derived it. It is E is equal to okay students, is the ratio of velocity of separation to the velocity of approach, or in other words we can say is the ratio of relative velocity of the separation to the relative velocity of approach. First of all, we have to recall back our memories about this law, how we got this equation. It's a simple thing students. Here, when the two bodies are moving along the straight line, we did in earlier video, and we learned that the momentum is always remains constant. What does it mean? If no external force acts on a system, the sum of the initial momentum must be equal to sum of the final momentum. For a two-body system, we got the relation like this. But let's say it is the first body, has a mass of m1, moving with a velocity of u1, and we have one more moving along the straight line. Okay, they are traveling along the same line, and here u1 is greater than u2. For a fraction of time, they collide and they stick together. Then after they get separated, and the bodies acquires the velocities of v1, and the second body is a bigger as a velocity of v2, and we got a relation as m of m2 u2 is equal to m1 v1 plus m2 v2. Okay, I am recalling back. That is, you can write m1 u1 minus m1 v1 is equal to m2 v2 minus m2 u2, or it can be written as m1 of u1 minus v1 is equal to m2 of v2 minus u2. Okay, we are calling it as the equation 1, and we are applying the same thing for their energies. Initial kinetic energy of m1 u1 square plus half m2 u2 square is equal to half m1 v1 square plus half m2 v2 square, and also it can be written as m1 u1 square minus m1 v1 square is equal to m2 v2 square minus m2 u2 square. Okay, then if we divide these things, say it as 2, and what we had, m1 of u1 minus v1 into u1 plus v1 upon m1 of u1 minus v1 is equal to m2 of v2 minus u2 of, okay students, we did this, v2 plus u2 divided by m2 of, okay, dividing v2 minus u2, and these terms get cancels here, and finally we had u1 plus v1 is equal to v2 plus u2. Okay, that is u1 minus u2 is equal to v2 minus v1. Okay students, and this equation is written as u1 minus u2 is equal to v2 minus v1. We call it as relative velocity of approach is equal to relative velocity of separation. In this way, we derive that expression. And if we take the ratio of the two, V2 minus V1 by U1 minus U2, we call it as the E, where E is coefficient of restitution. Okay, students, it is the expression for coefficient of restitution what I wrote here. Here I thought it is good to make you to remember the equation again. I think you got the value of the E is the coefficient of restitution. Actually, it will tell us how the energy will be lost or energy remains constant. Okay, that is the coefficient of restitution. And generally, the value of the E lies in between. Okay, it is E is from 0 to 1. I mean, the minimum value of the E is equal to 0 and the maximum value is equal to 1. Okay, students, here if E is equal to 0, we call it as perfectly inelastic collision. Okay, perfectly inelastic collision if E is equal to 0, and you know that if E is equal to 1, it is perfectly elastic. Okay, students, what does it mean? Here we can write E as I said it lies in between 0 to 1. Okay, E 0 is less than or equal to greater than 1. That means the remaining values lies in between 0 to 1. Either it is the inelastic collision or perfectly inelastic collision or head-on collision. And if you watch it clearly, you will find what's that. If E is equal to 1, let's put the value. We get E is equal to V2 minus V1 by U1 minus U2. Okay, students? Then what we get? If it is a perfectly elastic collision, I said E is equal to 1 V2 minus V1 by U1 minus U2. That is, the velocities will exchange. In the same way, take E is equal to 0. Then 0 is equal to V2 minus V1 by U1 minus U2. That is 0 is equal to V2 minus V1. That is V2 is equal to V1. In this way, but we can find out what is the perfectly elastic collision and perfectly inelastic collision. Okay, in a perfectly elastic collision, you will get the relative velocity of separation is equal to the relative velocity of approach, and it is the perfectly inelastic collision. I said is equal to 0. Then what we got? Just the velocities will interchange. Okay, students, let's do one application of coefficient of restitution. This is a very important application when we are solving the problems. It will be useful. Here, in this case, what we are going to do, we kept a body at certain height above the ground, and we make the body to fall down. The body came and it is the ground. Then after it will rebound. Let's say, okay, it is dropped from a height of h1. Okay, students, and it rebound to a height of h2. Okay, students. Okay. Here the ball hits the ground with a particular velocity. Let's say it hits the ground with a velocity of u1. Okay, students? And the ground, that means initial velocity of the ball which hits the ground, or the body which hits the ground, is equal to u1. Okay, students? And initial velocity of ground is the second body we are considering. It is u2 is equal to 0. Okay, students? Then we have to find out what is the initial velocity of the body. Here we have to consider the velocities when the collision took place. Often students mistook that it starts with 0 velocity. That means they u1 as 0. It is not. u1 is here the velocity with which the body hits the ground. Okay, just use the what's that basic concept of kinematics. We know that v square minus u square is equal to 2s is a freely falling body, and it traveled a distance of s, that is equal to h1, and acceleration is g. Okay, students? Here initial velocity u is equal to 0. When it hits, it has a velocity of v1, that is v is equal to u1. In the place of the v we have to write u1. Okay, u1 squared minus 0 is equal to 2g h1, or u1 is equal to under root of 2g h1. Okay, students? Here I am writing initial velocity of body or the ball. Okay, u1 is equal to under root of 2g h1. Getting, students? Okay, we got the u1 and u2 as 0. Then what about the v2? What about the v2 and what about the v1? Okay, students? It hits the ground with a velocity of u1. It means it rebounds. On reaching a particular point, it lost its velocity, final velocity. Then it begins to fall down. We are using the same principle, student. And also you have to think that the earth is very big when compared to the earth, when compared to the body. Okay, students? So there will be no change in velocity of the earth when the body hits the ground. So we are taking the final velocity of ground. Okay, students? v2 is equal to 0. Okay, students? Here we need the final velocity of the first body. v1 is equal to how much? Okay, students? We have to find out the v1. Okay, students, we have to find out the value of the v1. We are using the basic principle. Here v square minus u square is equal to 2s. Okay, students? After reaching this point, the velocity becomes 0 and it raises to a velocity of v1. We have to find this. Okay, students? And 0 minus v1 squared is equal to 2s, but it is raising up, okay, against the gravity. That's why a is equal to minus g. Okay, students, we need to find the value of the v1. See, the students, we have the relation E is equal to V2 minus V1 by U1 minus U2. Just substitute the values, what we got. E is equal to V2, obviously it is 0, minus, we need to find the value of the V1 by U1. U1 we got, okay students, root of 2g h1, and U2, it is the velocity of the ground, 0. Then we get E is equal to minus V1 by root of 2g h1. Okay students, or we can get V1 is equal to minus E of root of 2g h1. Okay students, now we are using law of conservation of energy to find the height to which the body is raised. Okay students, then what is the law of conservation of energy? Change in kinetic energy might be equal to potential energy. Okay, kinetic energy and potential energy are, what is that, interchangeable. Kinetic energy changes into potential energy and potential energy changes into kinetic energy. Here the body is raising to a height of h2. Okay, and when it hits the ground it has a velocity of v1, that is half m v1 square is equal to mg into h2. Get cancelled. Okay students, and what we get, v1 square is equal to 2g h2, or h2 is equal to v1 square by 2g, but we have the value of the v1 is equal to minus of e into root of 2g h1. Here we are substituting the value, that is h2 is equal to minus c under root of 2g h1 by 2g is whole square. Then h2 can be had as e square into 2g h1 by 2g, where 2g get cancelled, and we had h2 is equal to e square h1. In this way you can find out the height to which it raises, okay, after the first rebound. Okay students, h2, if you say h1 is equal to h and h2 is equal to h1, after the first rebound h1 is equal to e square h. It is the height to which the body raises after first collision. In the same way, if you consider the second, then you have to go e square into h2 h3. In this way you will get a relation. Okay students, okay, that can be written as what, hn is equal to, just think what it would be, e of 2n into h. Okay students, if you take the n rebounds, hn is equal to e of 2 number of rebounds into height. It is the formula to get the height after n rebounds.